We're going to work on the lead code problem asteroid collision. So this problem has been categorized as Lyft's most asked interview question of 2020. So essentially the problem is you're given an array of integers. So each of those values represents an asteroid. So a positive number means that it's traveling right and negative means it's traveling in left direction. So whenever they travel, in opposite direction, there is a possibility of collision, and when that occurs, the larger asteroid will cancel out the smaller asteroid. So here's an example where the input is 5, 10, minus 5. So 10 means it's traveling right, minus 5 means it's traveling in the left direction. So since 10 is a larger, it'll cancel out minus 5. So the result is just 5, 10. Here both of them are of the same value. So when that happens, they both cancel each other out. So that we return an empty array. Here's another example where 2 and minus 5. So minus 5 is larger, so it'll cancel out 2. And later, when 10 and minus 5 collide, 10 is larger, so this will be the only one which is returned. Um, Another thing we should consider is a case where if the first number is negative, the second number is positive. Minus 1 means it's traveling left, and plus 2, for example, means it's traveling right. So now they're traveling in opposite directions, so there's no possibility of collision. So collision only occurs if the current number is positive and the next number is negative. So when you're solving a problem like this, we need a data structure where we can always check which was the last value present in the array to see whether or not it collides with the current asteroid. So that's the reason the best data structure to use is a stack. So with a stack, what we can do is with the current asteroid, we can compare all the previous asteroids to see which one, when it is possible to collide with the current asteroid, and if which one needs to be cancelled out. So yeah, let's first create the stack data structure. So now we'll create a for loop to traverse down into the asteroids array. So first thing we need to check is what's the value of the current asteroid. If it's positive, we can just add it to the current stack because then there's no possibility of collision. So else, so the value is negative. We just need to compare with the values already present in the stack. If the stack is empty, we can just insert the current asteroid to it. If the stack is negative, that means the current asteroid and the previous asteroid are traveling the same direction. So again, there's no possibility of collision. And if the current value in the stack, it is, if it's smaller than the current asteroid value, so there's possibly, there will be a collision, but then the previous asteroid will be cancelled out. So let's try writing the code for that. So while oops, I can see a mistake. I think it should be greater than 0. Sorry. So here what we are doing is we are going to keep removing elements from the stack because the value of the current asteroid is larger. So that's why we check if the asteroid is greater than 0 and the value is less than the current asteroid value. So we need mat.apps because the value is negative. So in order to check which value is greater, we need to first remove the sign and just look at the absolute value of it. So the end of this, if So what we're checking if after doing the current operation, if the stack is empty or the value is negative, that means both the previous and the current are traveling in the same direction. So we just add the current asteroid to it. Else, if they're the same size, so both the asteroids are going to cancel each other, so we just say stack.pop. The other option is if the previous value is greater than the current value. So since the value is canceling out the current asteroid value, we don't really need to do anything. So we don't, so because the value already present at the top of the stack is canceling it out. So we do it until finally we reach the end of the asteroids array. So now we have a stack which has all the remaining asteroids. So in order to return, the result should be of type integer array. So we create an integer result. So new index size. Then for so the final thing we do is we create a array which will be used to store the result. And since in the stack the values are stored in the reverse order, we add the values from the end of the array. So let's try running the solution. Okay, all the four use cases pass, submit. So yeah, for this solution, the time complexity is O of n. So essentially what we are doing is we keep adding the value to the stack and we keep comparing it with, to see with the previous values. So in that case, it's a linear solution since we are going over the list once, and depending on how many values we cancel from the stack, that also is mostly, it could be like depending on what's the current value. Um, so the runtime complexity is O of n, and the memory complexity is also of O of n, since essentially the only thing we use is a stack to keep track of how many values are getting added.